你不用那么说了。好，用不完的。
Okay, so it's almost tied up. Now yeah, we take the second round. So opponent please try the problem.
We want to challenge problem number 10, magnetic here.
Number 10.
Okay. Reject.
And we want to challenge problem 8.
8. Reject.
Reject.
And we want to challenge number 13.
Number 13. Reject.
Okay, so the problem was posed by the opponent earlier is available now. 11 and 4.
Move on to challenge problem number 5.
Number 5. Accept.
Please write down your name. Alphabetical. It's also time for preparation. Reporter, please give the presentation.
Okay, so I'm this round reporters, and we are from the workshop, and we are going to report question 5 on market. So our problem statement is a pinball ball is placed in a containers of waters. When the containers is dropped, the ping pong ball will get launched to a great height. What maximum height can you reach with up to 2 liters of water? So like we are going to focus on water downstream and squeezing and flow reactions first, and what is the main reason that causes pinball ball bounce higher than the south to bounce. And we are going to deal with the phenomena, investigations, and experiments, and data analysis and conclusion. So for our observations, so when I drop something on the air cushions, the things on the other side will bounce up. Okay, so when the pinball ball flies, I could show like the water is mainly the reason that pushing out. So when a container that filled with the water is falling down, I could see the change shape of the water. So when this falls down in the videos, the water is being split out and separate, and when it falls down and crash to the ground and touch it, and we can show the changing shape from the middle part of the waters, and just like the wave of the water. So I can show like the movement of the pinball boats is really kind of like affected by the changing weight of the waters. And there is a comparisons on different heights of that experiment. So possible variable. First, the height that we both of the containers that we like make it full, and the shape of the containers and the area of the containers. So like the height that falls down the containers, we are affected. So because we are affected by if we making the container stay longer at the airs, and we will have the adding and increase up by the gravity and causing the increasing force, and the increasing force might translate to waters and to the ping pong ball, and the shape of the containers. So like the shape of the container will really connect it to the area of the container. So because like the shape of the container will affected by some kind of like round shape it or the square shape. So like round shape of the container might be the square of the container might lacking or like decreasing the wave. So when the water is falling down, the square container might be lost the wave and causing the wave that translates to the ping pong ball be decreasing. So if the container is being circled, and maybe they will not decreasing the wave. And the area of the container, by my opinion, is think about the area of container will affect it, because if the area is increasing, so the force that translate to the water will be separated, and if we separate the force, so ping pong ball only got the force at one dot 1 point. So if we saturate every point of the force, the ping pong ball might be having less force and flying shorter distance. And our experiment. And research purpose. So our research purpose. Okay, so research objectives. We're investigating. Okay, we just jumped into the third. So, for our question is mainly talking about how does the ping pong ball could fly furthest in 2 liters of the water. So we connect to the theory of this. So this theory is about how could the things translate, because this experiment is very related to a ball and a small ball and a bigger ball that is in the down of the small ball. So when we drop it, a big ball and a small ball together, and the small ball will jump higher than original when it bounces. So this is a theory about the big ball and the small ball. So it can be related to our experiment. So we can know that when the big ball is in the down, and big ball in the down is just like water, it will translate the force to the small ball, and we can see the small ball have the less weight than the big ball. So if we when the small ball contain large ball forces, then it could fly further. And calculation. And this is calculation of like the maximum height the ping pong ball could reach. And we need to apply projectile motions equations taking into account the internal velocity of the ball. So from this formula, h equal to v squared divided by gg. So where h is the maximum height, and we are changing the v and g volumes, and g is like the gravity. So for the v volume is the initial vertical velocity. And our equipment will be the water and rope and pulleys and ping pong balls. So because we want to have like control the variables, so we use the rope and connect it to the containers, and connect to the containers across the pulley. So make sure when we are putting down the containers, it will be flat to where it in touch the ground, it will be flat to the ground. Experiment with okay, the rope will connect to what I say, how I do to the experiment, and the container will always fill with the 2 liters of water that I will have the sign in the containers to make sure every time I put in the water will be the same. And with the ping pong ball falling, and rope, the other purpose of using rope is make sure to know the time that I can control the time that the container is falling. So the expected phenomena. So I expect that when we put the container higher places, we put it in higher placement, it will the force that the ground translates to water will be increased, and it might cause the ping pong ball fly further, and so I think that and also we change an experiment. So the maximum height the ping pong ball to reach will depend on variable factors such as the size and weight of the containers. The initial height form which is dropped, the volumes of water and the efficiencies of energies transferred from water to ping pong balls. However, predicting the exact maximum height without specific measurement and experimental data will be challenging. It will require detailed calculations involving and so that's our data. We can see the four different factors. One is the water volumes and in liters, and the water mass, and the initial velocity, and maximum height. And so for our conclusions, demonstrations of Bernoulli principles. So for this principles, it's saying like by levitating a ping pong ball with a stream of air from the hair dryers, we observed how fast moving air creates a low pressure area around the ball, allowing it to float. So the pressure differential keeps the ball floating. The levitation of the ping pong balls occurs because of the fast moving area, and we can see the air stream and stability without the air stream. Thank you, everyone.
Okay, so opponent please ask the questions.
On this page, you mentioned that this is a demonstration of Bernoulli's principle. And can you simply explain what?
So we can know in the Bernoulli principle is talking about the high pressure is going to low pressure, yes. So if we are saying about the high pressure is going to the low pressures, and in our experiment, we are deal with about the things because the ping pong balls is in the waters. So when the oil container is falling down, the ping pong ball will go into waters and.
Okay, thank you. I will go to the next question. So during the free fall of the container and the ball, so what will happen during this phase? Will the ball sink into the water, or it will keep at the surface of the water?
You say in what series?
During the free fall of the whole system.
Which side?
I'll go to the next one. So will there be a water jet that will pick the ball up?
Will the water?
Will the water concentrate at a point and push the ball up, or it's just the whole water that will, or like have a collision with the ball?
Okay, so because the water can be compressed, so when the water, it can be also flat and just compressed
Time's
out.
up. 2 minutes for the preparation time of the opponent. Honors, back below.
Honorable judges and fellow competitors, I'm the opponent from the team Musafir, and the problem I'm going to oppose is ping pong racket. Here's a problem statement. A ping pong ball is placed in a container of water. When the container is dropped, the ping pong ball will get launched to a great height. What maximum height can you reach with up to 2 liters of water? And the main focus will be what and how forces act on the ball, and what maximum height can the ping pong ball reach. And here's a reporter's outline. For the field report, he mentioned about the energy conservation and the Bernoulli's principle. And for the experiment, he had some experiment on different parameters, including area of container, the shape of container, and the height of water. And here are the strong and weak points of the reporter. So the reporter did explain about the phenomenon and how they conduct the experiment. He explained the theory, but however, there are many things that he didn't take into account, such as the Gaussian jet and the restitution of coefficient between the container and the ground. And he also didn't talk about the swirl. So if there is a swirl in the water, then what will happen to the phenomenon? And also for the material, he didn't talk much about how material will affect. Well, and here are the points to be discussed. So first about the launching. Well, I would like to talk about the coefficient of restitution between the container and the ground. And also I would like to talk about the Gaussian jet that is happening to lift the ball upward, and how it is formed and when it's acting during the whole process. And also I will talk about the force and if the buoyancy force is needed to be considered, and how will the capillary action affect the result. Also, during the falling of the whole system, I want to discuss about the sinking and the air resistance. For the parameters, I will focus on the diameter and material and shape. Also, there are some parameters that isn't introduced in the report. And this includes the swirl, surface tension, and hydrofacility of the ball. And about the experiment, I would like to know how the experiment is measured, and if the releasing method is stable enough to be reproduced. And the data analysis, I will focus on the air resistance and some deviation may caused by the drop angle of the container and the measurement of capillary.
โอเคจะถามนิดนึง Further discussion.
So what do you think is the main reason to leave the ball outward?
So I think the main reason is because the translated from the water, and because when the container is touching the ground, the force will cause the water is changing the shape from because the water will push off from two sides of the
Can you use
container.
the blackboard?
Yeah, sure.
What can you draw about what you're talking?
So I mean, when the container is like this, and the ground, we know the water is like ping-pong. So I mean, when the container is touching the ground, the water will change the shape. So when the whole container is full down, the two sides of water will lifting up and cause the wave. So next time will happen will be the ping pong ball because the water of the wave.
Can I first ask, why is the water shape like this? Why there is a curve like this?
Okay, so there is a curve because when we first sound, we can see two sides because two sides of the things that causing the force that touch by the ground. So
The opponent disagree with this explanation. So during the free fall of the whole system, so when the container is not dropped to the ground, and so here's the position of the ball, and if during the free fall of the container, will the ball sink into the water, or when it's dropped to the ground, will it sink into the water?
and why do you think it sinks to the water? And why possible?
And because during the free fall of the container, the whole system is accelerated at the gravitational acceleration, and therefore in this condition we can ignore the buoyancy force and the gravitational force. So in this case, the main reason to pull the balls into the water is the capillary force, and this is the main reason that there is a pressure built in the water, and so the water will, when the container hits the ground, the water will go to this point to fill the vacancy caused by the sinking of the ball.
And how can you know like this isn't affected? Because on the experiment I'm doing, the water do change shape, and water change shape, it will affect the movement of the particle too.
Yeah, so when the container hits the ground, there will be in our experiment we observed that there is a water jet that is pushing the ball upward. And we believe this is the main reason to lift the ball up. So when the container is dropped to the ground, will there be some other water splashing like around the central of the ball?
So that is like mainly that the variable that we are going to control. So we are going to make every experiment, it will be the same happening to this. So like the container that fall to the ground, it should be very flattened and parallel. we need to make sure this kind of variable every time will be the same. So it will happen like this.
Okay, then, well, can you turn to page 9? So in this theory, you have mentioned the work done on the object by external force. So what are the external force here?
First, I'm going to talk about this theory is not accurate. I mean, this theory is not the same with the experiment. I'm just suggesting because when I'm reporting, I have said about the other experiment is likely to be the same. Like a big ball that is under the small ball. So this is the experiment that we could be compared and knowing a more theory about.
Okay, so this theory does not fit the phenomenon well. So have you calculated about this theory?
Okay. This is a non-experiment.
So do you believe that if there is more water, the ball will be launched to a greater height?
But in the question we are talking about like 2 liters. What will be the height? So it is very weird that we are like changing the variables of the water, the volumes of the water. Because
so you believe that when the water is 2 liters and there will be a maximum height?
no, because we didn't sure about it. Because 2 liters is the question that is the fixed up numbers. We are asking that what kind of factor will change, make the pinball ball become higher, but the fixings of the 2 liters of water. So we can change the 2 liters of water.
Okay. So you mentioned about the wave that will be transferred to the top. And can you explain more about that? How will the waves affect the launching of the ball?
It's not waves affected. It's because when the ground is transferring the force to the water, it will cause the wave, and if the pinball ball is at the wave top of the spot, then it will be pushing off.
Okay, then you said that the water will be forming under the ball to lift the ball up. Well, so will this always happen even if the ball is not placed in the central part of the water?
So we are going to do more experiments. So make sure every the time. So we only get the data or only get the experiment that do happen that the pinball ball is in the highest of the water spot. So if it is not, then this time data will be cancelled out.
Okay, then about the shape of the container. So if the waves need to be transferred to the ball, the depth of the water and the radius of the container may affect. And how do you think this will exactly work?
Because like if the container is shaping in square, then we can see they have angle in it. But if the container is rounded, they have don't have angle. They have maximum it's round.
So you believe with a circle container, a round container, the ball can easily get launched to? PF5.
because the weight will not be decreasing.
And so, well, if the release height increase, will the dumping height always increase too?
Okay, so because it will be a very interesting question. Because if we always like making the container put it in very high, then will the ping pong ball go like further and further? No, because everything that falling down, they have the limit speed. So they will have the limit speed, and if the thing stops with the limit speed.
So opponent, please compare summarize the discussion.
Well, here's a discussion summary, and I believe that, well, if the ball sinks into the water, then there will be a pressure field in the water, and this will therefore form a velocity field form a water jet to lift the ball up. And we believe that, we agree with the reporter that if the container has a round, and that will be easier for the water jet to concentrate and lift the ball up. And we believe that if the releasing height is higher, and while the velocity of the water jet will also be higher. However, there is a limit because
Hands up. So reviewer, please stand up, asking the question for both.
Thank you to the reporter and the opponent for the discussion. And first, the question I want to ask is, do you consider different type of rock?
Yeah, I do consider different types of rock.
Thank you. And can you go to page 16? You said that you use the hair dryer for it. Did you actually use the hair dryer to shoot the air? What were you trying to using the hair dryer?
So like for like hair dryer, it will like make it proof like okay. So we know like there will be
It's fine. And for both the reporter and the opponent, first the opponent, in your diagram that you drew, there's no displacement of water due to the volume of ball submerged. Do you think that there should be displaced water that goes up like this on the above the surface of the water if you submerge the ball? Or do you think it's flat?
well, so besides the water jet, I think most of the other surface of water will be static. Well, there may be some scratches, but there isn't too much.
So you're saying that there won't be displacement due to volume? Yes.
Okay.
What do you think? Do you think it will be the volume of ping pong ball will displace water up?
yes, it will something, but it will be like
So do you consider it water jet or ping pong? Please answer yes.
yes.
Okay. Do you think water jet will affect the phenomenon investigation, forming the water shooting up? Can you explain how the water jet forms?
So since during the free fall of the container, the ball will sink into the water because of capillary reaction. And when it hits the ground, because of the vacancy that has created by the displacement of the ball, and
Can you elaborate more on the capillary reaction explanation? Like you're saying that the whole experimental process is like a capillary reaction, right?
during the free fall, because of capillary reaction.
And also, do you think there will be surface tension of water affecting the phenomenon investigation?
Yes.
Do you think so?
Yes.
Okay. And like you both said this experiment is similar to the big ball and small ball experiment, correct?
Yeah, it's
What do you think is the difference?
the difference is because the water is in liquid and the big ball is in the solid.
What?
Can you repeat the question?
Do you know the stack ball experiment where you saw two balls, the large ball collides and the small ball
Hands
accelerates?
up.
I think
Time's up. Sorry. So 2 minutes for the preparation time of the reviewer. The viewers, text below.
Okay. Hello, my name is Bill. I'm gonna have the name from honors from Taipei American School, and I'll be presenting gold. So the problem statement states that a ping pong ball is placed in a container of water. When the container is dropped, the ping pong ball will get launched to a greater height, and the what is the maximum height you can reach was 2 liters of water. And the main focus that reported focus on was the water buoyancy and the squeezing of water, and the flow reaction force, and also why does the ball reach higher heights. And for the report's performance, the phenomenon they talk about, drop something on an air cushion, the thing on the other side will bounce up, and the wave on the water will make the bounce. And for the theory part, they mentioned the drop height, impulse, and greater height. And they also considered the shape of container, wave interference, lower height, and the area of container, and the force distributed over area, and finally the lower height. And for the experimentation, they connected a rope to the container and dropped two liters for all their experiments, and filled container with ping pong ball to investigate the bounce. And the pros of their report is, I think they laid out the topic clearly with sophisticated vocabulary, and they had a clear voice, and they laid out the variables they wanted to investigate in this interphenomena investigation. And for the cons, they had unclear no photo of setup, and they had no videos of their experimentation, and they lacked graphs to show data, and that no experimentation setup shown, so we didn't really understand how their setup was performed, and they didn't really test their theory that they showed. And many of the slides come from other experiments, such as the hair dryer, and said the water is compressible, and did not explain what the theory were wrong, and the opponent had to clarify that. For the opponent, they brought up alternative theories to explain the phenomenon, such as the vortex of the jet containing a fluid restitution coefficient and store. And the pros, they mentioned various theories to explain the phenomenon, and they had lots of alternative scenarios. They also tried to clarify theories that were wrong. And for the cons, they brought up alternative theory instead of improving existing ones, so they didn't really focus on the reporter's theory, and they had little focus on the experimentation method of the reporter, and their time management could be improved since there are lots of points they said they would discuss, but they ended up didn't discussing. And this is the first discussion point of their discussion. It's the reason for the ball movement. And the opponent asked that what is the main reason the ball moves upward, and they said the pressure builds up during drop and causes the ball to fly over, with the jet being a side effect of the pressure release. And reporter said that when the container hits the ground, the force travels through the water and final jet is most supported. The reviewer agrees with the opponent that the water jet will be formed due to the surface tension and the displacement of water going in, shooting the water up, having other effects rather than conservation of energy. And for the second discussion point, they talked about the external force. And the opponent asked where does the external force come from, and the reporter said it's a proposed continuation of the theory. The reviewer said that thinks that instead of looking to generalize the experiment, the experiment theory should be developed. And they discussed about the wave, and the opponent asked about the wave in the motion, and the reporter said that the wave isn't most important, and wave pushed the water up. And we agree with the opponent that the wave doesn't really matter. And for the things they failed to mention, the data analysis doesn't really show a linear relationship, and we think the rate was too small. And the points missed was the surface tension, the drop height experimentation setup, and the drop height will be important since the phenomenon talks about how the maximum height is achieved, and they didn't consider it up to 2 meters, and they said only 2 meters.
Okay, so the reporter please give the concluding remark.
Okay, so in the questions that we are discussing is about what will be the maximum height that will reach up to 2 liters of the water. So for me, we now know like the container could put in the higher and higher, but they will have a limit speed at the end, and it will be harder to control other factor. So, and because I also think that the shape of the container will also affect. Just like Ross said, if I put container size just like the ping pong ball length, all the force that translate to the waters will all have the same translation to the water to the ping pong ball, and it will cause all force that causing by gravity will all touched by ground will all translate up to the ping pong ball, and it could make it to the maximum height. So we have the height, and we make the shape that is similar to the ping pong ball sizes. Thank you.
Okay, so now it's time for pressure from theory. So maybe I ask the pressure first. So I would like to ask the three of you. So maybe from reporter, and opponent and reviewer. So do you think what is the most important parameter to hit the maximum height?
Okay. You say what factor is more important?
Yeah, just one. Yeah, tell me one.
Okay, I think the size of the container.
Okay. So opponent.
I think it's a mass of water.
Sorry.
Mass of water.
Okay.
I think it's a drop.
Drop. Okay, so question from Jerry.
Just curious question about the opponent. Why you have mentioned that the capillary actions, but why you need to consider that because the size of the ping pong ball is much larger than the capillary length?
Because during the free flow of the container, if we take the container as a reference frame, and because it's non-inertial, and in this case the gravitational force and the buoyancy force can be ignored because of the equivalent acceleration.
So you mean the effective gravity is equal to 0, that's why the reason the capillary length increased drastically when you consider capillary actions. Then do you agree with that?
As you mentioned that the ping pong ball is really large compared to the capillary, I don't think capillary actually should be considered. And also, rather than, I agree with the reporter that the force buoyancy and the gravitational force will be equal. However, there will be a surface tension force of the water that's pulling the water down on the ball, since when the ball is submerged, there will be a certain amount of water around the ball like this. And since turf tension, it wants to go back to its position. In this position, there will be force of the surface tension as a net force react on the ball in free fall movement.
For me, because I just say that if I make the size of or the shape of the container be like a ping pong ball, and we can saw that water might be fly out, and the ping pong ball will also be pushing out.
So, any other question from you?
Okay. For the height, okay, drive from the air to the ground, and for the height, okay, the ball reach the height. What the distance?
Yeah, again.
Okay, because you do the displacement and the water and the drop, okay, and the ball reach in the height. Okay, so you show any data from to show you the height the ball reach.
Like the relation.
Ten centimeter.
I
1
think
meter.
so. Like the maximum height will be. Maybe I write it.
Okay.
So, other question?
So, just curious, what's the initial velocity on the curve? Can you tell me?
So the materiality is about every second per meter. So we note because the height of the maximum height and the initial velocity might be have the connection.
So which means that you change both the water volume and the initial drop in velocity?
No, we change this one and
You have two variables there.
so we are changing the height.
I think time is up. Yeah, it's okay. So, theory for scoring now. Okay, now it's go for reporter. 3, 4, 1, 4, 3. Score for opponent. 6, 7, 6, 5, 5. Reviewer. 6, 8, 6, 6, 8. So, do you like to give a comment? Maybe one that you can give some comment.
Yeah, I would like to suggest you provide, for example, this is a really a dynamical process that you can provide an actual, for example, a movie showing that how the merger is laid out, how the experiment is conducted, to let people know how the experiment is
Okay, so if no more comments, oh, okay, one more comment here.
Well, I think the tournament is kind of tiring, so, but the problems are interesting. So I think we should all have some more fun. Okay, just.
Okay.
One more thing I would remark. Also for the conclusion, because you cannot make something in the conclusion that you didn't mention in the previous part. For example, the air dryer, you didn't mention in previous report, but you certainly shown all this result in the conclusion.
Okay.
Okay, if no more questions, so let's end this section. And maybe we take a 10-minute break. Okay, come back here earlier and shift your table first.